The following is a brief introduction to the Data Discovery and Query Builder product's user interface. DDQB, as it is commonly known, is used for building ad hoc queries to discover information from large and usually complex databases. When we build queries in DDQB, we refer to a concept called the model entity, and the model entity is the center of the query from which all other criteria will be based. You can have either specific model entities or arbitrarily choose one. In our case here, we will use the patient model entity against the sample database for building our query. When looking at the building of a new query in Data Discovery and Query Builder, what we're presented with is a view of the data abstraction model. That is the list of concepts available for us to query from. And as we can see, we can drill into the different concepts and drill down to specific attributes that we're interested in. Here, for example, we'll select the gender and choose to build a condition. And what we're presented with in each step of the process is specifically what options are valid for either the field, the concept, or the data of the underlying database. The goal behind this is to make an environment in which it's nearly impossible to build an invalid query. As you can see, by walking through that simple set of steps, we've chosen the gender criteria for our patients to be male, and it's been automatically added to the output. There are a number of preferences within the DDQB product for controlling the way the user interface works. And for our ease of use here, we're going to change some of our data abstraction model preferences and allow for quick selection of output for our individual fields. We'll show that in just one second. After building a query condition, we return to our Data Model tab, where we will select additional information for output. And we may drill into the birth and age related category, and this is what the preferences have allowed me to do, is simply quickly select to add another field to the output of my query. If I go back to my query, we'll see we still have our condition. We now have an age output. If we go ahead and run this query, you see that what comes out is a mapping of the age information, the gender information, which we've only selected one gender, and the list of patients from our database that meet that criteria. With this done, we'll close our set of results, and we'll be prompted for whether or not we want to save them, and we will choose not to at this time. And we're able to, even though most users do not, it's useful at times to be able to look at the SQL underlying the scenario that we've put in place. And what we'll see here is a number of mapping functions that have been put in place automatically by the data abstraction model in order to get the right information for the user. Of note also is a condition that we did not request specifically, but is a security requirement within our environment, that we don't return information that would violate protocols and policies of our organization. So based on the information touched within the database, automatic conditions are also applied to our query. Returning to our query at this time, we will now begin to add more complex information to it. For example, if we close the demographic subcategory and look at the diagnostic category, we can drill into our ICD-9 codes and choose to pick a set of specific ICD-9 codes. And here you see we have different options available to us, again based on what the abstraction model allows. In this case, we're going to grab a set of values, and I've prepared this set of values in a different file, which I'll simply drop in at this time, and we'll create that condition. We'll also demonstrate the ability to use unstructured information within this environment by going into the clinical notes, selecting to query on the original documents, choose to build a free text condition, and we'll search for the term nausea within our documents. By adding a term to the list of terms, we build up a criteria that will be searched just like any other within the environment. Here we'll simply use one term and add that to our query as well. So as you can see, our list of conditions is growing as is our list of output fields. If we go ahead with this and run our query, what we end up with is the requested pieces of information, and we've intentionally here narrowed it down to just one patient, and we're able to look at their clinical note document by simply clicking on it, and you'll see that the free text hits show up immediately within that document, offering validation of what we were looking for. So we will close that document at this time, and we'll go back and from our query results go all the way back to our query definition model, and rather than looking directly for the value, we will search within our abstraction model and find one of our laboratory tests. Even though the abstraction model is built around our personal concepts and domains in any given installation, it can still be much easier to find concepts based specifically on a search as opposed to having to navigate complex hierarchies. Selecting that particular lab test, we'll see we're again presented with the list of options available for that given field, and we'll choose to build a range condition, which would allow us to specify an upper and lower limit. In this particular case, so we're going to use the upper and lower limit of 1, and we're going to use attributes that we've associated with this field within our abstraction model for the lower limit of normal, abbreviated LLN, and the upper limit of normal, abbreviated ULN. Now these attributes are specific to individual values within the abstraction model for gender, age, race, and things of that nature. And basically what we're saying is we want the values for the individuals we're looking at to be within the normal range given that individual. Beyond being able to do this type of condition to a specific field, we're also able to build subfield conditions, which are additional criteria that further limit any individual condition. So while we're looking for values within the normal range, we see we have a whole host of possibilities for limiting that further. And here we'll build a range condition on the age specific to that particular lab test. And we'll say we were looking for people who are between 10 and 20 years of age for that given test, or at the time of that given test for them. So creating that condition, again, we could build a whole list of conditions here, but eventually we would apply this set of conditions to our laboratory test condition. You see we get a summary of the additional criteria that are going along with our condition on amylase. If we now create that condition to our query, we again see that we have the normal condition with the further limiting criteria based on the age. We also end up with the values in our output. Running this query, you'll see we get for output our individual again who is 55 years of age, but at the time of their amylase test they were only 14 years of age. So they fit the criteria we limited the amylase test values to. Again, demonstrating the ability to look at retrospective events within a patient's history in the process of selecting the individuals. The final information that we wish to convey in this introduction for getting people started is that all query results can be saved so that they can be shared with others or retrieved later based on the security policies of the organization. We can also save the queries for future add-on work. So if we switch to the query tab, we're able to again select that we wish to save the item in question, and we will say demo query and save that. The repository of information here after we close all open tabs is available immediately off of the home page where we can see the information that we've saved. I hope this short introduction helps you get started with the Data Discovery and Query Builder product, and we look forward to seeing you on DDQB Central in the future. Thank you.